In this video, I'll be going over the BattETL package design and the BattDB database design. So let's go ahead and get started. So BattETL is a Python package for extracting, transforming, and loading battery data to a database. Let's dive into the specifics of how this works. So to start, we have our battery test data. So that looks like a battery stats file, battery data files, one or many for a single test, depending on if it's split over multiple files. A scheduler procedure file, depending on if it's a Arbin or make or cycler, and any other associated schedule files, like a fastwave file, an FRA file, a canned config file, something like that. The scheduled procedure file and other schedule files are actually optional, but we encourage you to include those because it's always good to store this information. So that's sort of our raw battery files. And then we also have our BattETL config. And I'll get into the details of what's held in there sort of as we're walking through the program. So to start, we take all these raw battery data files, and we extract them with our extractor. So that takes them and turns them into data frames. So the raw test data is turned into a data frame, a single data frame, and the stats file is turned into another data frame. And the schedules and associated schedule files are turned into a nested dictionary where you can access them. And these are all accessible from your BattETL object. You can work with the raw data frames and the schedules however you like. And the thing we get for the extractor from our BattETL here is the paths to these files. So the BattETL has to define the paths to these files. So that's defined in our BattETL config. So once we have our sort of raw data frames, we take those and we take them to our transformer. And so what this does is it sort of normalizes the format of our battery cycler data. So, we convert everything to voltage millivolts, amps goes to milliamps, and we normalize for cycle stats how the capacitor is reported. So we give two distinct columns for charge and discharge capacity, kind of following the Arbin convention there. And so we get all the units and data types consistent across all cyclers and in a consistent way to load to the database. So what we take in from the BattETL config here is the time zone information, because another thing we get is Unix time. We find that's a really great way to work with battery data because it's independent of time zone, and it's a simple just ticks up. You don't have to take into account any of that. So we find that's a great way to work with data within our databases. So we love working with the Unix timestamp as a individual column there, and that's part of what's generated in the transformer. So out of the transformer, we get our transform test data and our transform cycle stats. So directly after this transformation step, we calculate some cycle statistics here. And those are just like your standard cycle statistics you usually get from the cycler stats file, but we calculate those independently based on the schedule file if it's provided. And that can be useful just as an independent check, or sometimes with typos in the scheduler procedure file, those aren't calculated correctly if you forget to reset capacitor or something like that. We also calculate some additional cycle stats like CC and CV charge time to 15, 80%, things like that. And it's also possible here to inject your own sort of transformations on the cycle stats data or the actual test data if that's something you would like to do. For more details on that, check out the README. But that can be a really useful step because sometimes for specific tests you have to do weird specific transformations, and we support that as well. So once we've transformed the data, we go to our loader, and this is responsible for loading the transformed data to the database. So from the BattETL here, we get all sorts of test metadata, and I'll kind of go over that once we're looking at the database here. So we've taken all that test metadata and all of this, and we load all of it to the database. So what does this database look like? Let's go over here and take a look. So this is the structure of the BattDB database. So let's kind of zoom in here, start at the left, and work our way over. So cells meta, this is information specific to the type of cell we're testing on, like the manufacturer and the manufacturer part number. Think of it as like the cell model. This is a one-to-many relationship with the cells table. So each cell's instance here comes from a single type of cells meta, right? Like our manufacturer part number, and then for a specific cell, we have like a manufacturer serial number. And again, all of this information is included in the BattETL config. You don't have to include all of it. For the cells meta, it's like the manufacturer part number, and cells, it's a manufacturer serial number. So you don't have to include all this information. And if you wanted to modify it to include more information, you can do that. This is all open source. So that's sort of the cells meta to cells relationship. And it's a similar relationship with our cyclers meta to cyclers relationship. For a cycler, we have like a specific manufacturer and a specific model, and that is a one-to-many relationship to cyclers, which has the specific cycler serial number, calibration, whatever other information you want to include there. Schedules is sort of a similar relationship as well, except we just have a single schedules meta table, and this has the schedule name used, date created, the cycler make, and here's where we actually hold the schedule files as well, loaded up into JSON objects. Cool. Now all of these, we have a cell, we have a schedule, and we have a cycler, and that feeds into our test meta information, right? For an individual test, we have a specific cell, we have a specific schedule, and we have a specific cycler. And so those feed in here and have this strict relation that allows for writing queries and things of that nature. And this includes information like our test name, any thermocouples, the specific channel we're using, and all of that. And here, it feeds into a one-to-many relationship to our test data table, where all the actual test data, the transformed test data we upload, lives. And we also have a test data cyclestats table, where all the transformed cyclestats data lives. So the power of a structured table like this or a structured database rather, is it's really easy to write queries for like, show me all the test IDs for a specific cell. So it's very easy to track the test history of an individual cell, or show me all of the tests for a specific make of cell. So it's really easy to write sort of these cool, powerful queries. And likewise, for the schedules, you could say, show me all the tests that use this schedule. And it just really enables a lot of powerful data analytics. So thanks for watching, and please let us know if you have any questions regarding this.